Alright, so we're going to get into some algebraic application of some of our geometry here. So we're going to talk about Pythagorean theorem, special right triangles, and sine, cosine, tangent. And sine, cosine, tangent is especially important as you move on into Algebra 3-4 or Trig. But let's start here with Pythagorean theorem. So Pythagorean theorem says, and I'm sure we've all heard this before, it says in a right triangle. Now that's important. This only applies for right triangles. So a right triangle is a triangle that has a right angle or a 90-degree angle. It says the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So hypotenuse, remember, is the side that is opposite the right angle, so this is the hypotenuse. And this is saying that if I have, we'll use the letters that you're probably used to, call this A, and this is B, so those are the legs, and this is the hypotenuse. This is saying that in a right triangle, a squared plus b squared equals c squared. Incredibly important. Okay, you'll see this a lot, and probably one of the few things that people remember about their math classes is that little phrase right there. But remember, that only applies for right triangles. Down here on the bottom, then I have another theorem that says if the squares of the length of one side of a triangle is equal to the sum of the squares of the other, then you can say it's a right triangle. So in other words, if you are given, let's just say, we'll do a simple example here. Let's say I'm given a triangle like this, and this is 3, 4, this is length 5. And the question is that a right triangle? Well, I don't know. It doesn't say it's a right triangle. Well, this theorem down here says, well, if you use Pythagorean theorem and it works, essentially, then you can say, yes, it's a right triangle. So in other words, if I can say, oh, well, does 3 squared plus 4 squared equal 5 squared? Well, let's see. 3 squared is 9, 4 squared is 16, and 5 squared is 25. So yeah, I would say that's true. And so since that works, then I can go ahead and say, oh, well, this is a right triangle. That's what that theorem says. Well, let's do an example here. So let's say I come up with another triangle. And I don't know, we'll say, we'll call this 7, we'll call this 25, call this right angle, call this x. And I just want to know, all right, well, what does x equal? Well, Pythagorean theorem. So remember, the hypotenuse here is always the a squared plus b squared equals c squared. So the hypotenuse is always this part right here. So in this case, it would be 7 squared plus b squared equals 25 squared. Well, now you just do a little bit of algebra, and let's see how good you are at algebra. So, question is, what's 25 squared? Hopefully you know that's 625. 7 squared, hopefully you know, is 49. Subtract 49 over 49, and you end up with 576. Well, how do you solve that? Well, hopefully you remember to solve b squared equals 576, you square root both sides. And you can just take a calculator and do this. The square root of 576, okay, square root of b squared is b, square root of 576 is 24. So b equals 24. And there you go. Pretty simple right there. So let's keep moving. Alright, now, there's special types of triangles. There's one that's called a 45-45-90 triangle. And there's another one that's called a 30-60-90 triangle. And we'll talk about why those are so significant here in just a few minutes. But let's actually just write down what they are. So it says a 45-45-90 triangle theorem. In a 45-45-90 triangle, both legs are congruent and the hypotenuse is, and I left it blank here just in case somebody would know, but hopefully you're thinking to yourself if you know it, is root 2 times the length of a leg. Okay, so in other words, if I draw a picture, so it's a 45-45-90. So this is 90, this is 45-45. Okay, and one of the things that we've kind of skipped over in our short time together is if these angles are congruent, okay, that means their sides opposite are congruent. And so in a 45, 45, 90 triangle, that means this side is congruent to this side. So it says those angles, or pardon me, up here it says those both legs are congruent. So in other words, if we just use x, this is x and this is x in length. It says the hypotenuse is root 2 times the length. So in other words, if the leg is x and this is root 2 times it, so this is x root 2. So a pretty simple example is if I gave you a 45, 45, 90, so say it's 45, 45, and let's say I called this 6. So that means this has to be 6, because if these are both 45, then opposite sides here have to be the same. And then by this theorem up here, says if I know that this is 6 and this is 6, and this has to be this times root 2. So in other words, it's 6 root 2. Not super tough right there. Now it can get tough. I mean, no doubt about it. We can make it a little bit more challenging. Let's say I did another example here. Okay, we'll do 45, 45, 90. What if we said that this was x and that this is, I don't know, 5? How would I figure out what x is? Well, you can do it a couple different ways, really, but this theorem up here we have says that this is this times root 2. Well, this is 5. Well, again, this is saying, look at this, it's saying that 5 should equal x root 2. Okay, that's what this is saying right there. Look at that. This should equal this. So solve it. Well, let's go back to your algebra days. Divide by root 2. Okay, you can get 5 over root 2. Okay, and then if you're really good, you'll know how to rationalize that. And by rationalizing it, you would have to multiply by root 2 over root 2, which would get you 5 root 2 over root 4. Okay, I'm going to go this way, sorry. And square root of 4 is 2, so you get 5 root 2 over 2. So this would equal 5 root 2 over 2. Now, if you don't know how to do this whole part, rationalizing it, no big deal. You can just leave your answer like that, 5 over root 2. Okay, that would work just as well. All right, let's keep moving. So another theorem is a 30, 60, 90 triangle theorem. It says in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is, and I'll fill it in, root 3 times the length of the shorter leg. Alright, so what the heck does that mean? So let's draw it first. So this is one where we have a right triangle again, but it's not the nice pretty 45, 45, 90. Okay, where this angle right here is 30 and this is 60. Okay, so it might be worth mentioning, since we've skipped over it in our class, is that there's a theorem that says that the longest side is always opposite the biggest angle, and as you go down, the shortest side is opposite the shortest angle, the middle size angle is opposite the middle side. So as I'm looking at this triangle right here, the hypotenuse is always the longest, so that's always opposite 90. And then since this is 30, that means this is the shorter side. And since this is 60, this would be the middle side. So in this theorem, it says the length of the hypotenuse is twice the length of the shorter leg. So if I say the shorter leg is x, then the hypotenuse is 2x. And it says the length of the longer leg is root 3 times the length of the shorter. So There you go. And so a pretty simple example, okay, would be if I gave you a, let's just do this one more time, 60, 30. I said, oh, well, this is 5. So then what are all the other lengths? Well, all right, well, that means opposite the 90 is twice that, so that's 10. Opposite 60 is just the shorter leg times root 3. Now, it's not always that easy. We can obviously do another example that makes it a little more challenging. I promise I'm not going to try and hurt your brain here, but let's say we do a triangle like this, and this is 30, and this is 60, and let's say I tell you that this is 4 root 3. Okay, so opposite to 60, okay, opposite to 60 is 4 root 3. So remember, opposite to 60 is always x root 3. So what's x? Well, x would then obviously have to be 4, so this would be 4. And opposite 90 is twice that, so this would be 8. Okay, and there you go. Okay, there, again, we can get some more and more challenging ones, but that's the basic gist of it right now. Okay, I promise we'll get into some more challenging ones. Okay, last thing we're going to talk about. So a little thing that's called SOHCAHTOA. Maybe you've heard it, maybe you haven't. But SOHCAHTOA, and I wrote it kind of funky here, so SOHCAHTOA. Okay, it's not always written like that. Sometimes people will write it kind of the traditional way. If I write it like that, it'd be SOHCAHTOA. Okay, and really what SOHCAHTOA is just a kind of a fancy way to remember some ratios. And so when we're talking about right triangles again, okay, it doesn't matter whether it's a 45, 45, 90, 30, 60, 90, a 20, 70, 90, it doesn't make any difference. And so what exists are certain ratios, okay, and this is the beginning of trigonometry. And it says that when you have an angle, so let's just say angle A here for a moment, okay, angle A, okay, the angle A, okay, is equal to the ratio of the sides opposite over hypotenuse. So in other words, that sine, okay, is a fancy word, okay, it's a fancy word, okay, and it means opposite over hypotenuse. So in a triangle, it's every right triangle, this ratio exists, okay, and the ratio of angle A, so in other words, the sine of angle A, so forgive my writing here, my writing is actually not 100% accurate. Should say the sine of A is always going to equal opposite, so opposite of A would be opposite, okay, so it would be BC over the hypotenuse, AB. And we'll get into what the heck that means, okay? But the thing that you really need to remember is that sine, okay, that's why we have it written like this. Sine is equal to opposite over hypotenuse, okay? So opposite over hypotenuse. Okay, another ratio that exists is cosine, okay? And cosine, that's the C, okay, means adjacent over hypotenuse. So if I talk about angle A again here, the side that's adjacent to it, okay, so that would be this side right here. Okay, so cosine of A would be adjacent, so AC over the hypotenuse. Or if we just talk about in general terms, that's this part, cosine equals adjacent over hypotenuse. I guess I can't erase it. I thought I was going to be able to erase that, but it's not. It doesn't want me to. Oh, there we go. How about that? All right, so cosine equals adjacent over hypotenuse. Okay, and then you have tangent. Okay, so tangent, okay, so if we talk about this angle again, okay, this is this part right here, okay, is a fancy word for the ratio of opposite over adjacent. So we've already talked about opposite, okay, opposite over adjacent. So if I say the tangent of A in this triangle, it would be opposite, so it would be side BC over AC. Okay, or just in general terms, if you want to say tangent is equal to opposite over adjacent. Alright, so there's a whole skill here in just being able to do that part. Alright, so let's say I have a triangle. Just for argument's sake, we'll change the letter D, E, F. And we'll just give some numbers here. We'll say 3, this is 4, and 5. And I say, alright, let's start with angle D here. Now, there's some abbreviations I should go through. That's sine. Okay, most times it's abbreviated SIN. I know it looks like sin, but you still say sine. Cosine is abbreviated COS. Again, it looks like cos, but you still say cosine. And tangent, TAN. So if I say, tell me what the sine of angle D is, I'm asking you, tell me the ratio of the side that is opposite over the hypotenuse. So you would tell me, oh, well, that's 4/5. Okay, hopefully not super tough right there. Erase part of my stuff there. What if I said cosine of D? Then you say, all right, well, here's angle D. So adjacent over hypotenuse, so you would tell me 3/5. What if I said tangent of D? You would tell me opposite over adjacent. So it would be 4/3. Okay? So you can hit pause here and try this. So figure out what sine of F is, cosine of F, and tangent of F. Here, ready? Go. Hit pause, do it. Alright, so hopefully you did that. And so if you came up with sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. Okay? Pretty good stuff right there. Alright. So and that's actually where we're going to end, because we're going to do the rest, even though this is kind of opposite of what we normally do. We're going to do the rest in class, okay? But hopefully that's a good start.